Hello everybody and welcome back to another visual pattern challenge. Here's our pattern today. Here's step 1, step 2, step 3, and your challenge is to determine how many of these purple squares are in step 4. If you can do that, can you tell how many are in step 43? And can you write an equation that could be used to predict the number in any step at all? That's the challenge. If you'd like to accept it, pause the video and see what you can do. All right, well, so we've just got lines of these squares that are getting longer, and looks like they're getting longer pretty quickly. So I don't know if this is linear or if this is maybe something bigger than linear, but it does appear to be growing pretty rapidly. I think the best thing to do here is just to try to see the previous step in the next step and then see what's been added. So we've got 3 here. I'm just going to mark off those 3. And looks like we've added 1, 2, 3, 4. Okay, so that would be 7 there. So let's try to mark off those 7. I think that would be the 7. And then we've added 1, 2, 3, 4. Aha! So it looks to me like we're adding 4 and adding 4. So we'd probably add 4 more. So that would be, well, we had 7 plus 4 is 11, and 4 more should be 15. So I think there are 15 in the next step. Let's just quickly analyze these numbers. This won't take us too long. I'll make a chart with the step number and the number of squares in each step. So in the first step, there are 3. In the second step, there were 7. In the third, we counted 11. And in the fourth, we're predicting 15. To analyze the numbers in a pattern, we usually take the difference between each step. So 7 minus 3, that's 4. 11 minus 7 is 4. And 15 minus 11 is 4. This probably doesn't surprise you. We're adding 4 every time, so the difference between the steps is going to be 4 every time. When you have a constant difference between each step, that means the pattern is linear. And we can use the equation for a line to model that. So y equals mx plus b. And that m, the slope of your line, is actually this rate of change, the difference between each step. So we can start with y equals 4x. Now, we don't know what the b is, but we can find out by just seeing how this equation works with step 1. What we're going to do is substitute the step number in for x. So y equals 4 times 1 instead of x. And the y is supposed to tell us the number of squares. In this case, it says y equals 4 times 1. That would be 4 squares. That's 1 too many. So to get down to 3, we just have to subtract 1. So we subtract 1 there, and that means our b here is -1. So our whole equation is y equals 4x minus 1. We can verify that this works in step 2. Y equals 4 times 2 minus 1. 4 times 2 is 8, minus 1 is 7. That's how many we've got. How about in step 3? Y equals 4 times 3 minus 1, and 4 times 3 is 12, minus 1 is 11, and that's how many we've got. So our equation looks like it's working. Y equals 4x minus 1. And now, to calculate the number in step 43, we just plug 43 in for x. So y equals 4 times 43 minus 1. And 4 times 43, well, 4 times 40 is 160, and 4 times 3 is 12, so that's 172. Minus 1 is 171 squares in step 43. Well, how'd that go for you? Did you get 15? Did you see that it was a linear pattern? Let me know. Thanks, everybody.